Erwin, second issue which we need to talk about after the structural design is all additional impacts you as a structural engineer are taking care of, which is, say, bomb blasting if it's really hard, it's burglary, it's fire, and we also need to talk about how do I get it in position? So is there anything about scaffolding I need to take care of? Are the glass sizes too big? Things like this. Yeah. So again, aluminium system, wood system, steel system, as we sketched it, as we designed it, the situation like this, the main grid like this, as we agreed on, the idea about tolerances, which is shown, and here the main system. Let's start with scaffolding. How would I build it? How would I build it? I would just start placing the sticks and then adding the glass. Ground, no problem. First floor.
It starts from what how the detailing is about. So is detail about working from inside out or from outside in?
Here we can work from outside in.
Yes. So then you, of course, start with the mullions.
Okay.
That's the best idea. And then, and of course, you have to. I think you have to have a kind of cherry picker to fix it at the top position, because you and me, we're not 4 meters long,
nope.
Unfortunately. So we need a cherry picker to get there.
So okay, at a cherry picker, you wouldn't install a scaffolding thing, you would actually do it with a cherry picker?
Well, for this size I would, because then I have the opportunity to get all the paints in. Otherwise, if I have or scaffolding, it's very hard to get all the paints in.
So if we have a scaffolding which is like this, with say the 2 meter floors, level, nice, okay, but then you have to somehow maneuver the glass plates at the back.
And glass is brittle, so keep that in mind.
Okay, so cherry picker, there's enough ground at the surface, so I can place it here and then get in position, fix the detail, get in position, fix the detail. Then installing all the components, and then the glass itself will be brought there as well, again with the cherry picker. So it's going to be fixed at the cherry picker. So I'm going to have, say, a device, something like this, with an arm, and then wheels, and then this whole thing is going to move, go on.
And of course,
and the person,
somebody who will install it.
And then the glass pane are going to be placed here with vacuum fixation and then brought in position.
Yes.
Okay, that's a simple one. It's also not a huge size, so that would be something which would work. Okay, that's a simple one. Scaffolding done, check. The details we talked about, and now impact. Well, let's talk about impact here. What about, say, a person impact, which I assume would only happen here in this lower part. So when we talk about the person, here it comes, it may bounce into the facade. But what kind of load do I have to count?
Well, it's very funny, because this situation does not exist in the codes. Because you only have a horizontal force when you can fall down.
Okay.
So, funny enough, there are no rules for this one.
Okay.
But it's wise to have, I call it a shoulder load, that somebody can hit. So, I would say, well, if somebody of 100 kilograms will hit, so you have a horizontal force, it's 1 kilonewton.
Okay.
Then you're on the safe side, and then it's going to be okay.
And as we hit like this, this is kind of soft body. It's not a sharp edge, so it's a soft body impact of 1 kilonewton, which we assume to happen somewhere in this line. We don't expect that to happen here because no one is able to go there.
There's no floor. There's no floor here.
If we have a balcony, this may be different. But that's a different story.
Yeah, and then somebody could fall down from inside outside, and then you have the rules which say you have some extra load.
Okay. This is body impact. What else can happen? Imagining this is going to be a super important building, and we expect
an embassy.
And we expect a risk of bomb blasting, which is the maximum extreme. It's not detailed like this, but what would we take care of if we would need to think of?
Well, you have to imagine that people do not die from the blast itself, or from tables falling down. people get hurt because the shattering of the glass. So you have to prevent the shattering of the glass. And here you had one of those nice horizontal details. This one is already nice. So what you would like to prevent is that little shatters of glass, that this one breaks, and little shatters of glass will be like a projectile go to anyone. So it's very important to have a laminated glass, so that there are two panes or even more laminate together, so that there will be no shattering of glass. And of course, there is always this foil in between. So you have to really connect this foil there. And it's like well, how you call it? It's like a cable. It works like a cable. So it's very elastic cable. So it's very important.
In case of blast, that whole thing is going to somehow find this way. Then the glass is going to break into pieces. But the foil being fixed, not in this system, different system, going to be fixed in here. And of course, we can imagine then the aluminium piece needs to be a lot larger because it needs to withstand that impact.
And the glass will stick to this foil, so nobody will get hurt.
Okay, that's the idea. So we actually allow the facade itself to somehow deform, get destroyed, but not start to fly as a projectile. That's pretty much the point. Okay, this is structural impact we talked about. This is bomb blasting we talked about. Then the burglary. Burglary. Yeah, let's talk about burglary here. How can I open it? Well, when I think about the details, which we saw, we take off the cover cap. Well, then we have the screw. And then.
Well, burglary is about how much time does a burglar need to get in. So this one, what type of screw do you use? A simple one. Or there are also burglary screws.
So if it is something like this, well, then it's a simple one with a screwdriver. I take it off. But if I get to something which say gets more complex as geometry, this may be. Can I somehow lock it? Can I glue it?
Of course, but it takes more time. And you could also think about this cap. Maybe I already have some bolts there, so I cannot get it off easily. So it's only to delay the time to get in. So if I can have several layers where I can delay it, then you're on a good way to make it a burglary proof.
Same, I guess, is for the glass. So if I just break the glass, it gives noise. I don't want that. Okay, if I have laminated glass, then breaking it is going to be a lot more complicated.
Yes, and the more layers you have, the more complexity, the more time it will take that you can get in.
Impact, soft body in person impact, bomb blast, burglary, we talked about. What about fire? In case of fire, we take the horizontal cut because fire normally gets upwards. So imagining there's a fire here, and imagining this is a floor. What do I have to take care of? I just draw it a bit as a floor. It's not in this detail, but I imagine it being a floor. What happens here? There's a fire here.
What you have to prevent is that fire from here goes to there. That's not what you like to have. So you have several options. You can make the glazing fireproof,
which means it's a laminated glaze with this liquid in between.
Yes, it's like a foam, and if it gets hot, it will expand, and it's like an insulation. That's how fire protection works in glass. You could do it. So you could do it here, but you could also do it here. So you could also make this one, this facade fire protected.
Same setting.
Same setting, or you could divide it. You could say, okay, 1 + 2 is my total fire resistance. So you could also think
30 minutes here, 30 minutes here, and that makes it 60 minutes. So. Next setting, smoke. Anything about this? If I seal it here, well, smoke will not find its way. If this is a solid piece, smoke will not find its way. That's a kind of setting.
And of course, this should not be burnable. So it always has a fire class.
Okay, so this should be kind of not burnable as a setting. Okay. We talked about bomb blasting. We talked about soft body impact. We talked about the scaffolding, the construction itself. I think we did all the jobs which I need to get from you as structural engineer. Let's go back to the one with the construction. This is pretty much it. Thanks.
You're welcome.